Hello everyone, in this video I will wrap up on the topics on risk and return of a portfolio, and this covers the material in the chapter 12 in Jordan book. Uh, so just to recap for what we've learned so far, so a portfolio is a combination of different assets, and a portfolio return simply equals to the weighted average of individual assets return. Okay, so those W's are the true weights that you put on a single asset, and those are the expected returns for individual assets. Okay, so the portfolio return is very simple. However, for the portfolio risk, it's slightly more complicated because oftentimes it is smaller than the weighted average of individual assets risk. Okay, this is because when you combine different assets together, there's a diversification benefit. So you get to reduce some of the risk in individual assets. Okay, so the portfolio risk, this is the variance of the portfolio equals to this equation. Those W again, those are the weights on individual assets, and those sigmas are individual assets standard deviation or variance. And the rho is the correlation coefficient between any two assets. Okay, so the rho measures how do the returns of two assets co-move with each other. Okay, it ranges from -1 to 1. So if there's any confusion for what we've covered so far, the full version notes is already in the Dropbox folder, so you can always go there and check. Okay. So the objective for this video is that we'll be talking about a model called Capm. Okay, so those are the things that I expect you to understand after this video. Okay. Now, so here we'll be talking about the capital asset pricing model. In short, it's called Capm. Okay. Now, what is it about? Okay. The most important question in the investment world is what returns do we expect from an investment? Okay. Now, this will largely depend on what return do you require when you purchase the assets. Okay, so in other words, it depends on largely on your required rate of return. So for example, if when you purchase an asset, you expect the future cash flow to be 106 and you want a 6% return, then you should pay 100. That will give you a 6% return, right? So the question is, what should be the required rate of return? Okay, there are many models that tries to answer this question. Among all those models, Capm is the most classical one, and it lays the foundation of many other models. Okay. Now, one thing I want to point out before we jump into the details of the model is that the actual return you end up with, oftentimes it's different from what you expect ex ante. Okay. So in other words, your realized return might be very different from your expected return. This potentially because your expectation of the future cash flows is wrong, or so on and so forth. Okay, but those are the uncertainty or risk that investors have to face. Okay, so now what is Capm about? We've talked about in the previous lecture that when you're investing in an asset, the required rate of return should equal to the risk-free rate of return plus any compensation for risk. Okay, the risk-free rate of return covers two parts, right? It covers the real risk-free rate of return, which compensates for your patience in consumption, and also it covers the inflation premium, right? So the purchasing power of the money goes down over time, so you need to be covered for that as well. Now, compensation for risk is also called risk premium, right? So the higher risk investors take, the higher return we want, because generally we don't like risk. Okay, so that is in general. Okay, now what Capm does is that it goes into more detail. It says that the required rate of return should equal to risk-free rate of return plus compensation for risk, but investors will only be compensated for systematic risk. Okay, we'll talk about what is systematic risk, but generally it is one type of risk among all the risks. Okay, so it says that we will only be compensated for this type of risk. Okay, therefore it will equal to the risk-free rate of return plus the amount of systematic risk on any asset plus the compensation for each unit of systematic risk, right? So those two combined together will equal to the compensation for the systematic risk for an asset. Okay, so in the rest of the slides, we'll first talk about what is systematic risk, how do we measure it, and how do we come to this equation. Okay. So, what is systematic risk? We have learned that by combining different assets together into a portfolio, we get the diversification benefit. Okay, so if an investor wants to be optimally diversified, what he or she can do is to hold the market portfolio. Okay, it is the portfolio that includes all the economy's assets, and the weights are so carefully chosen so that the risk is minimized. Okay, so when we remember that when we introduce the risk of a portfolio of two assets, the portfolio weights plays a very important role in determining the portfolio risk, right? So the same logic carries to a portfolio of many more assets. Okay, so the way we call it, the reason we call it optimally diversified is because the weights has to be chosen so carefully, okay, just to minimize it. So that's why we call it optimally. Now, when an investor is already diversified to the largest extent by holding the market portfolio, there are still some risk that remains in the portfolio. Okay, that type of risk is called undiversifiable risk. Okay, so again, those are the risks that remains even if you're diversified to the largest extent. Okay. On the other hand, the risk that is eliminated through this diversification process is called diversifiable risk. Okay, so the total risk in any investment can be decomposed into those two parts. Okay, so let me give you an example just to show what is diversifiable risk and undiversifiable risk. Now remember the example we had in the previous lecture. If you're running a business that sells sunglasses and sunscreen, okay, each asset is faced with the risk of weather condition, right? So when it's raining, you get to sell a lot of umbrella. I'm sorry. So it should be the example of sunglasses and umbrella. Okay, so both of those are faced with weather condition risk. Okay, when it's raining, you get to sell a lot of umbrella, and when it's sunny, you don't get to sell any umbrella. So each asset has the risk of weather condition. Now, if you combine those two assets together, you eliminate the risk that generated from the weather condition, right? So if you combine those together, when it's raining, you get to sell a lot of umbrellas, but you don't sell the sunglasses, right? So therefore, your return is kind of stabilized. Okay, if you don't remember, just go back to the previous lecture's notes. Okay, so those are that the weather condition is a type of risk that can be eliminated in this example. However, think about the economic condition. Okay, if the whole economy goes into recession, you don't get to sell much of any of those two assets, right? Either umbrellas or sunglasses. Okay, so that is the type of risk that you cannot eliminate. Okay, because the economic downturn can affect all the assets in the market. Okay, so no single asset can escape from that. So this is an undiversifiable risk. Okay. So now, to be more general, what types of risk can be diversified? Okay, so if an asset, if it's a risk that results from factors that are firm specific, okay, not market wide, such as whether a new product succeeds or fails, the performance of a senior manager of a single company, those assets, those risks is firm specific. Okay, it only affects one firm or a small group of firms or a small group of assets. Right, so those risks can be eliminated if you combine different firms or assets together, because some are affected, some are not. Okay, so you can eliminate those. That's why diversifiable risk is also called unsystematic risk, because it's not systematic. Okay. On the other hand, the undiversifiable risk is oftentimes called systematic risk, because it must be the risk that is so systematic or market-wide that it can never be eliminated, right? So, those are the risks that is associated with, let's say, economic growth, inflation, interest rate, or political events, wars, and so on, right? So those are the events that affects all the investment potentially in the same direction. So you can never diversify those away. Okay, so that's why those are called a systematic risk. Okay. Now, the next question is, how do we measure systematic risk? Okay. Uh, Remember in the previous slides, we say that the systematic risk is the risk that all the assets share together, right? So now if you look at a single asset, the systematic risk must be the part that leads to the correlation between co-movement between the assets return and all the return of all the assets, all the other assets, right? Um, so therefore, we can, to measure the systematic risk, we can measure the extent to which a particular investment return could move or vary with the return of the market portfolio, right? So that, in other words, we can measure the part of the return in one asset that is shared with all the other assets in the market. Okay. Um, so the measure that we often use is called beta. Okay, it's another Greek word. Mathematically, a firm's beta is the slope of a straight line that best fits the relationship between an individual stock's return and the market portfolio's return. Okay, let's look at an example first. So here's, let's say if we want to measure the return on the systematic risk of Home Depot. Okay, so what we can do is we can plot the return of Home Depot against the return of the market portfolio. Okay, so this dot would tell us that when the market return is 5%, what is the return of the Home Depot, right? If we plot all the dots and we find the line that best fits all those dots, the slope of this line will tell us what is the runs divided by the changes in the Home Depot's return divided by the changes in the market return. Okay, and that tells us how does Home Depot's return change with the market return. Okay, so let's go back to here. So the slope will equal to the rise in individual assets return divided by the runs in the market return. Okay. Again, in other words, it tells us when the market return changes by, let's say, 1%, how much does the assets return change? Okay, the larger the slope, that it means these assets co-move with the market to a larger extent. Okay, in other words, the systematic risk is higher. All right. So another thing I want to point out is that although we keep talking about the market portfolio, it should be a portfolio that consists of all the assets in the market. But in reality, it's so hard to construct such a portfolio. Okay, it's very hard for you to just purchase all the assets in the market. So oftentimes we just use some proxies of a market portfolio. A very commonly used proxy is the S&P 500 index return. So S&P 500 index tracks the collective rate performance of the most important 500 stocks in the US market. Okay, so it is close to a market portfolio, but not exactly. Okay, but this is what we can, the best we can get. Okay, and there are, of course, there are some other indexes that people sometimes use as well. So to calculate the slope of this line, what we do is we look at the changes in the Home Depot's return. It's 6.7%, and to lead to this change, correspondingly, the market return changed by 10%. Okay, so the beta is 0.67. Okay, and this line actually should go through here. Okay, there's a little mismatch here. Now, how do we interpret beta? The way we interpret this 0.67 is that it tells us when the market return change by 1%, the Home Depot's return change, on average, it changes by 0.67%. Okay, so that's the way to interpret it. You might wonder, in reality, how do we calculate beta and how do we find the line that best fit? You can actually use some statistics tool. So you just run a regression of an individual assets return against the market portfolio return. Okay, but if you don't understand that, that's totally fine because those numbers can be found in a lot of online sources such as Yahoo Finance. Okay. So here are a few more examples of how to interpret beta. So when beta equals to 0, that means this asset is not quite affected by the market movement. Okay, because when the market moves, let's say by 1%, this asset moves by 0, right? And 0.5 indicates that this asset is half as responsive as the market. Okay, so that means when the market return change by 1%, on average, this asset with a beta of 0.5, its return change by 0.5%. Okay, and if beta is 2, that means when the market return change by 1%, this asset's return change by 2%. Okay, or when the market increase by 1%, this asset's return increase by 2%. Okay, a positive beta means that this asset moves in the same direction as the market. Okay, most of the time the assets have positive beta, meaning they move procyclically, right? So when the market is good, the assets also perform well. When the market is bad, the assets also perform poorly, right? So that's for most of the assets. But for very few assets, they actually have negative beta. So for example, if the beta is negative 0.5, that means when the market return increase by 1%, this asset's return will decrease by 0.5%. Okay. So a very good example of the negative beta asset would be the gold, right? So gold is considered a very safe investment, right? So when the market is doing very well, people tend to buy less gold because the other assets can give you a higher return, right? But when the market is doing poorly, they oftentimes put their money in the gold market just to keep the value of their assets, right? Because gold can preserve the value. So gold often has a negative beta. So some other important points to remember about beta. Beta measures the undiversifiable risk of a security, or it measures the systematic risk of a security. The beta for a market portfolio will be 1 because the change in market portfolio divided by the change in market portfolio is equals to 1, right? So the market portfolio is as responsive as itself. Okay, so that's 1. And the beta for risk-free asset will be 0 because risk-free assets, its return does not change with any kind of risk. It's not going to be affected by risk. And in theory, stocks could have positive or negative beta, but most stocks have positive ones. Okay. And stocks with beta greater than 1 are more responsive than the average market fluctuations, and therefore are riskier than average stocks. And stocks with beta less than 1 are less risky than the average stock. And because greater risk is generally linked to higher return, the higher a stock's beta, the greater its expected return. Now, this is the model prediction, right? Because the higher risk, we generally dislike it more, so we want higher return. Okay, but in reality, according to some tests, that this does not hold that well. Okay, just to keep in mind that. It's just a theory prediction. Now, the next question is, now that we've known how to calculate beta for a single asset, the next question is, what about the portfolio beta? So the portfolio beta measures the systematic risk of a portfolio. It simply equals to the weighted average beta of individual assets. Okay, so the W's are the weights, the betas are the individual assets beta. So here's an example. Consider that there's a portfolio that consists of 3 investments with betas equal to 1.2, 0.7, and 0.25. One half is invested in the first one and 1/4 in each of the remaining assets. What is the portfolio beta? So here's the answer. The weights would be 50% on the first one and 25% on the second and third one. And then we just multiply the weights by the individual assets beta and add up everything. So that means the portfolio beta is 0.8375. This means that when the market return moves by 1%, on average, this portfolio return will also move in the same direction by 0.8375%. Now, what if the first asset in this example is a risk-free treasury bond? Now, what changes in this one is that the risk-free treasury bond will have a beta of 0, as we've talked about in the previous slide, right? So if we replace this one with the treasury bond, this 1.2 becomes 0. Okay, so we can see that by adding the risk-free assets, the beta actually reduces greatly, right? So that means now our portfolio is much less risky. Okay, reward to risk ratio, okay, or market risk premium. Another insight from the Capm is that since investors care only about the systematic risk, then the assets that have the same amount of systematic risk should have the same return. Okay, so think about what would happen if this doesn't hold. If there are 2 assets, A and B, they both have the same systematic risk. Let's say beta both equal to 0.1. But A gives you a higher return than B, then what you're gonna do? You are all gonna go by asset A, right? Because why not? We're taking the same amount of risk, but we get higher return. Okay, so if we all go by A, then that will drive up the price of asset A and lower the return of asset A. Okay, so eventually those arbitrage activities will lead to will cause the returns of asset A and B to be the same. Okay, so that's the other insight. So which means there must be a one-to-one relationship between the return of F on assets and the risk. Okay, so we can plot the returns of required rate of returns on all the assets against their risk. Okay, so the line that best fits all those dots, okay, will tell you what's the relationship between required rate of return and risk. Okay, sometimes some dots are not on this line. That's because there are some other noise that could also affect those return. Okay, So the slope of this line will equal to the rise in return divided by the runs in the risk. Okay, here the risk is measured as beta, okay, because we're only talking about systematic risk here. Now, this slope will tell us for each unit of the change in beta, what is the increase in the return. Okay, so there, in other words, it tells you the compensation for each unit of systematic risk. Okay, so that's why this is also, the slope is also called reward to risk ratio. Okay, so now the question is, how do we calculate the slope? Okay, in order to calculate the slope of this line, we can actually use any two dots, right? The changes between any two dots can give us the slope. Now, what if we find the two very special dots? Okay, one has a beta of 1, and this corresponding return will equal to the market return. Okay, and another dot, let's find the one that has a beta of 0. Okay, so 1 minus 0 is changed in the beta, but the corresponding return is going to be the market return and the risk-free rate of return. Remember, when beta is 0, that's the risk-free asset. Okay, so by using those two dots, things actually becomes quite simplified, right? So it's simply equal to the expected market return. So that's the return you expect on the market portfolio minus the risk-free rate of return. Okay, and this is also called market risk premium. Okay, so that is the risk premium that you receive by holding a market portfolio. Okay. So having this in mind, we can represent this market security line in a mathematic version. Okay, so the required rate of return on each asset should equal to the risk-free rate of return plus the amount of systematic risk of this asset measured by beta times the compensation for each unit of beta. Okay, so in the previous slides, we already said that this compensation for each unit will equal to this market risk premium, right? So we put it here. All right, so that is the final Capm model. Okay, so here's an example. Suppose the beta for Nike is 0.92, meaning that on average, when the market return increased by 1%, the Nike's return will increase by 0.92%, right? If the risk-free rate of return in the economy is about 3% and the market risk premium is 5%, what is the expected return for Nike? So here's how we do this. The expected return should equal to 3% plus the beta, which is the amount of systematic risk, times the compensation for each unit of systematic risk, which is 5%. So you should expect 7.6% of return from this Nike stock. Okay. So now after this video, don't forget to do the quiz. All right. So I'll see you in class.